Now, in this video, we will going to take up one more problem on projections of lines, problem number 57. We will try to analyze this and also how to do it in sketchbook. So the problem reads as: the distance between the end projectors through the endpoints of a line AB is 60 mm. The NDA is 10 mm above HP and 15 mm in front of VP. The NB is 35 mm in front of VP. The line capital AB appears 70 mm long in the front view. Complete the projections and find the true length and its inclinations with HP and VP. So here he says the NDA is 10 mm above HP and 15 mm in front of VP. So when you look from the front view, we can see the distance NDA, which is above HP by 10 mm. And when it is projected, that is projected onto the vertical plane, which will going to be small a dash, and you are going to get this as capital A. And 15 mm in front of VP. So in front of VP, so that is this distance of in front of VP. So when you look from the top view, that image is projected onto the horizontal plane, where you are going to get it as small a and capital A here. So that distance is 15 mm in front of VP. The NP is 35 mm in front of VP. So from XY line, you measure 35 mm and draw a horizontal line. So you are going to get the locus of B in the top view. Once you get the locus of B, and then he says the distance between the end projectors through the end point of a line AB is 60 mm. So we have the distance from here to this line is 60 mm. So when you draw this, so you are going to get the top view, and then you project that 60 mm here also. So you will going to get in the vertical plane also that end projector distance will going to remain same both in the front view and also in the top view. So you got the 60 mm here. Then once you get this, then he says the line capital AB appears 70 mm long in the front view. So he has given the distance here. Since we know the end projector distance in the front view also, from A dash you measure a distance of 70 mm and draw an arc. So you're going to get this B dash and join A dash B dash here. So you have got the front view and you have got the top view. Now when you project this and when you project this from B and B dash, both will going to intersect at this point. So you will go into this point as capital A and capital B. Now we have got the line in space. Now we need to find out the true length. To find out the true length, first what I will do, with A as center, taking the radius of capital AB, which is in space, you rotate it such that both capital A and capital B1 are in front of VP by 15 mm. So that now the line is parallel to VP. So when it is projected in the top view, you will going to get this small AB1. So when this has been done, so what happens to the image in the top view on the horizontal plane? So the AB with A as center, taking the radius of AB, it has been rotated and make it small AB1 is parallel to VP. So since it is parallel to VP, so when you are projecting this, you are going to get the true length in the front view, which you mark this point as B1 dash and then join A dash B1 dash. So this will going to be the true length. So here when it is the image, so when you are projecting here, so that projection will going to start from here to here, and then you have this projection when you are doing it from the front view. When you are looking from the front view, that projection will going to come from here still it touches the locus of B in the front view. So that becomes B1 dash and you mark this as capital B1, then join A dash B1 dash. Similarly, if you want to find out the true length in the horizontal plane, so to find the true length in the horizontal plane, with capital A as center, taking the radius of AB, you rotate it such that both A and capital B2 are above HP by 10 mm. So when you are doing that, what happens? What happens to the image in the front view? The image in the front view also with A dash as center, taking the radius of A dash B dash, you are rotating such that both A dash and B2 dash will be above HP by 10 mm. So now that line will going to be the parallel to HP. So capital AB2 is the line which is parallel to HP in space. So when it is projected, that projection will going to come directly here onto the locus of B. So which is that from B2 dash it has been projected here. Then from here to here we have this projection. So because due to that, when you look from the top view, that projection will come from here to here such that it will going to cut the locus of B in the top view. And you mark this point as small b2 and join AB2. Then you measure that inclination phi with respect to VP. And you measure the inclination with respect to HP with true length, which will going to be theta. So now this is how we will be able to analyze this problem in 3D. Now we will going to try to take up in step by step. So once you take that, first we will going to have the XY line. So we have 10 mm above HP and 15 mm in front of VP, and here this has got 35 mm in front of VP, and he has given the distance between the end projector's distance, which is 60 mm. So when you draw this, so it will going to cut the locus of B in the front view, in the top view here, and you mark this point as small b, then join between small a to b with a dark line. So you have this capital A and you have capital A. Then what happens, since he has given the front view, you from A dash, you measure a distance of 70 and cut it on the distance between the end projectors. So you will going to get this as B dash. Once you get this B dash, join A dash, B dash with a dark line. Then you got the locus of B in the front view. So now I need to find out the true length in the vertical plane with A as center, taking the radius of small AB. You rotate it and make it parallel such that both A and B1 are parallel to XY line in the top view. So its corresponding front view, so that is A dash, and then draw a vertical projector from the top view B1 such that it will going to cut the locus of B here. So you mark this point as B1 dash. As we know that the top view line is parallel to XY, its corresponding front view, which is A dash B1 dash, will going to be the true length. Join A dash B1 dash with little bit thicker than the XY line, and you mark this as capital B. And you mark this as AB1, A dash B1 dash. Then join A dash B1 dash. So this will be able to find out the true length. The true length will going to be 73 mm when you are doing it in manual. When you are doing it in computer, it is 72.80. And also the inclination made by this with respect to HP is theta, which is 29.69 degrees when you are doing it in computer. When you are doing it in manual, it will be 30 degrees. So that is what we have shown here also with AB. You rotate it and make it parallel. Then you will going to get the true length in the vertical plane. Now similarly, when you want to find out the true length in the horizontal plane, you rotate the front view line and you make it parallel such that both A dash and B2 dash is above HP by 10 mm. Once A dash B2 dash is above HP by 10 mm, therefore the line is parallel to XY line in the top view, the front view. Once the line is parallel to HP in the front view, then what happens when it is projected? It will going to be projected onto the locus of B here, and it will going to cut the locus of B here, and you mark this point as small b2. Then since this line is parallel to XY line, so obviously this line will going to be in the true length. So you mark this as small ab2, which will going to be thicker than the XY line. Then you identify, you measure the denote this angle by phi, which is the true inclination with respect to VP. So it will be 16 degrees when you are doing it in manual. When you are doing it in computer, it will be 15.95. So this is how you will be able to find, and also the true length of this will going to be 72.8. So obviously this will going to be 73 mm. And now when you are doing it in computer, it will be 72.80. So this is how, and also you can see in 3D analysis also, when the line which is in space, you are rotated and make it parallel to HP. Once capital AB2 is the line which is parallel to HP, so you are getting the true length in the horizontal plane. So correspondingly, the image in the vertical plane is getting rotated, and that both A dash and B2 dash is above HP by 10 mm. Since it is parallel to HP, so you are getting the true length in HP. So this is how you will be able to analyze this problem in 3D and also in stepwise. Now we will try to solve this problem by using the sketchbook. So first we will going to draw the XY line and mark VP and HP as shown. Then you take the distance above HP by 10 mm on the above XY line because it's seen in VP. So you draw a horizontal line. Similarly, from XY line, you measure 15 mm below XY line and draw a horizontal line because it is 15 mm in front of VP. In front of VP distance is seen in HP. So then consider any point on that horizontal line and then draw a vertical line so that you will go to mark this point as A dash and A, and this as capital A and capital A here. Then you measure from XY line, you measure the distance of 35 mm because NB is 35 mm in front of VP. So from XY line, you measure 35 mm and draw a horizontal dash dot line. And then he says the distance between the end projectors is 60 mm. So from XY line, you measure 60 mm and draw a vertical line parallel to this projector A, so that it will going to cut the locus of B in the top view here, and then it is extended in the front view. So once it cuts the locus of B in the top view, so you're going to get this point as small b, then join A to B with a dark line. Then you take from A dash, you measure a distance of 70 mm because the front view line appears to be 70 mm long. So he has given the front view distance. Then by using the compass with A dash as center, take the radius of 70 and cut an arc on this end projector line, which will go to cut this point B dash. Then mark this point as B dash and draw a horizontal dash short line here. So once you get this, so you have the front view. Now we need to find out the true length. So to find the true length, with A as center, taking the radius of AB, by using the compass, you rotate it such that both AB1 is parallel to XY line in the top view. So that means both A and B1 are in front of VP by 15 mm. Then from B1, you draw a vertical projector so that it will going to cut the locus of B here. And you mark this point as B1 dash. As we know that AB1 is the line which is parallel to VP. So therefore, you are getting the true length in VP. So you mark this point as B1 dash and also mark this point as capital B. Then join A dash B1 dash with little bit thicker than the XY line. So then you are going to get the true length here. Similarly, with A dash as center, by using the compass, you measure the distance from A dash to B dash at the radius. Draw an arc such that both A dash and B2 dash is above XY line by 10 mm. So A dash B dash is A dash B2 dash is above HP by 10 mm. So now the line is parallel to HP. So its corresponding top view will be in true length. So from B2 dash, you draw a vertical projector so that it will going to cut the locus of B in the top view here. And you mark this point as B2. Since this line is parallel to XY, so you are getting the true length here. So you mark this point as capital B. Then join A and B2 with little bit thicker than the XY line. Then you measure this inclination with respect to VP as phi, and you measure this inclination with respect to HP, that is the true length, will be theta. By using the protractor, you measure the angle theta with respect to XY line. So that will be 30 degrees. And with respect to VP, that will going to be 16 degrees. By using the scale, you measure the length of the true length, which will going to be 73 mm. So this is how you will be able to analyze and solve this problem by using the sketchbook. Thank you.